We're going to be talking about sequences. And a sequence is an ordered list of numbers that often form a pattern of some sort. Each number in the sequence is called term of a sequence. For example, let's look at the sequence 5, 8, 11, 14. The first term is 5, the second term is 8, the third term is 11, the fourth term is 14, and so on. And we can identify a pattern. The pattern here is each time we move from one in the sequence to the next one, we add 3. This would be a sequence. And in fact, this would be what we call an arithmetic sequence. It's considered an arithmetic sequence because it has what we call a common difference, which means going from one term to the next term is increased or decreased by the same value, either add or subtract. We call that the common difference. In this case, the common difference is plus 3. So this is an arithmetic sequence. Let me show you another example of an arithmetic sequence. 3, 8, 13, 18. The common difference here is plus 5. This is another example of an arithmetic sequence. Here's a third sequence. This would not be considered an arithmetic sequence because it doesn't have a common difference. Here the difference is 3, but then here the difference is 4, and the difference here is also 4. So this would not be an arithmetic sequence. For sequences, we can write two kinds of formulas to describe the sequence. The easiest is the recursive formula. And the recursive formula simply describes each term in the sequence by the term before it. So, for instance, in our first sequence, we had 5, 8, 11, and 14. And we realized that the common difference was 3. So what we would say is the first term, and we indicate terms by writing almost like function notation, but in this case our function's a. So a of 1, the first term, plus 3 equals a of 2, the second term. So this is sort of a recursive formula. What I mean by that is the second term in the sequence is being defined by the first term in the sequence. We can generalize this to say the nth term of a sequence, meaning any term in the sequence, is equal to the term before it, and we write that as a of n minus 1. So the nth term in the sequence is equal to the term before it plus 3. And that's a generalized recursive formula for this sequence that we have here. This is what the recursive formula looks like. And it's pretty easy to set up because you just have to find that common difference. There's also something called the explicit formula. An explicit formula is a little bit harder to derive sometimes, but it's much clearer and more useful for finding terms of a sequence much further away. So let me show you what I mean. Here's the generalized formula for the explicit formula of a sequence. So the a of n, some term n, a of n is equal to a of 1, or the first term, plus, in parentheses, the term we're looking for, minus 1 times the common difference. So let me show you what this would look like in relation to a formula we've talked about. If I was going to find, let's say, the explicit formula for 3, 11, 19, 27, I would first need to find the common difference. Looks to me like the common difference is 8, but I want to check it everywhere to make sure that's true. Yep, the common difference is 8. So then I would say that the explicit formula would be this. any term in this sequence, a of n, is equal to the first term, 3, plus whatever term I'm looking for, minus 1, times 8. And there's your explicit formula. A of n, whatever term we want to find, is equal to 3 times the term before it, 3 plus the term before it, times 8. And that's how you would find the explicit formula of a sequence. The important thing is memorizing and having down this formula for finding the explicit formula. Okay, write that down in your notes, memorize it, and be aware of it, because it's sometimes hard to remember, but that's really, really useful. And that's arithmetic sequences and formulas.